Hello, this is Tubal Cain again. Today's discussion is about the principles of a Stirling engine, or what makes the Stirling engine run. And the best example I can think of this is get your old physics book out and read up on Boyle's Law. If you remember old Bobby Boyle from England, he's the one that developed all of the information on pressurization, expansion and contraction of gases, and really what we have in here is a gas, although it's just the atmosphere, but it's in a sealed system. Some of the more fancy Stirling engines use a gas like helium or something else, and it's pressurized. But here we really don't have any pressure, and the reality is there'd be minor leaks here that could get in around the piston or around this displacer rod, but everything else is sealed here. So we consider it to be a closed system. Remember that there's a hole drilled through here and then plugged that connects, and it goes through here and it connects the two sides. It's about a 1/4 inch hole on this particular engine. Now, when we heat up this end, we have a displacer on this side. Now this is not a piston, this is a displacer, and it goes back and forth, and it simply moves the gases from one end to the other, and that's why we call it a displacer. Now it does not fit very tightly inside of that tube. In fact, it necessarily fits rather loosely, with about a 1/16 of an inch on either side. It is not a piston, it is a displacer. It produces no power at all. The power is produced on this side. It's simply moving the gases from one end to the other. This is hollow, but it could be solid. I make it hollow to minimize the weight. This is aluminum. Some engines even use styrofoam. One of the other engines I've shown you use styrofoam, but if you get very much heat, of course, it would melt. This too has to be sealed. If there was a little pinhole or something in here, then you would have inefficiency. You want this to be sealed. Now on this side we have the piston, and the piston here is, let me get that out. Did you hear it pop a little bit? It's just a piece of steel and a connecting rod, but it's a very good fit, and it should pop a little bit like a champagne cork when you pull it out of there. And if it doesn't, that means that it's either too tight or it's too loose, and the engine will not run very well. Now in the next segment I'm going to illustrate to you what happens here when we heat this up and when we move the gases from one end to the other, and we cause the gases to expand when it's up at this end and contract on the other end. This principle was invented by a man by the name of Reverend Stirling over in England, and that was about 120, 130 years ago. And so they had Stirling engines a long time ago. In fact, they had them long before it was practical to build such a thing, that is, the materials and the machine tools that could be utilized in order to manufacture such an engine. But in the meantime, along came the steam engine, which was really much more powerful. Okay, stand by for the next section where I explain what's taking place inside of here. Okay, the engine is heated up now by this fuel, and you can use any kind of fuel. I just find out that the sterno here is real convenient, but it's been preheated a little bit. Now, I've taken the piston out, and over the end of this power end, I've placed a, well, you may think it's something else, but actually it's the finger out of a pair of gloves. But as I rotate this flywheel, you notice that the balloon, we'll call it, inflates and deflates. So what's happening here now is that as the displacer moves to this end, it is moving, it's hot, the air to the cold end, and it's contracting. As I rotate it and the displacer comes to the back end, all of the air is up here where it's hot, and it's expanding and it's filling the balloon. This is probably the best way that I can think of to illustrate the pressure change. Now remember, there's a hole drilled here originates here and it runs from the piston, power piston, over to the displacer side. Okay, the engine is still hot, and what I've done for this portion of the demonstration is I put the piston back into the cylinder, but yet it's not connected here at the crankshaft, and I'm going to rotate this, and you will see that the piston and connecting rod is moving in and out. Remember that with a Stirling engine, this is what is driving it. The displacer is only going along for the ride, being propelled by the power from the power piston side. So you can see it moving in and out, in and out, in and out. And next I'm going to put the pin back in here in the crank pin and allow it to run momentarily, which you've seen in other videos. Okay, I've replaced the piston, connected the connecting rod, still got the heat on. I got the engine running just to show you the complete cycle of what's happening here. You can stop it at any point, and a little spin will get it started. Remember, these engines are very inefficient. Probably 90–95% of the heat is being wasted. It's just going into the air. Some of them have a small furnace built around them to contain the heat, but they're still very inefficient. And this is a heat engine, and it is an external combustion engine. I said external combustion. All of the combustion is taking place outside of the engine. This is Tubal Cain saying, so long for now.